Hello, my name is Brian Lewis and I'm an instructor with J10S. Today we're going to talk about fire safety and prevention at work. We're going to talk about some of the principles of fire and the chemical reactions and how to prevent heat and some of the other things like oxygen and fuel from coming together and having that combustion process. Before we get started though, I would like to ask you to pause this video and discuss any kind of near misses or accidents you've had at your facility or out in the field. And then when you're finished discussing those and coming to some way that you can fix the issues or make sure they don't happen again, simply press play and we'll continue with the video. Thank you. Hopefully you have discussed any near misses or accidents and we'll get started. So today we're going to talk about the fire triangle. We're going to talk some about gasoline vapors. We're going to talk about how to eliminate fire hazards, obviously. We're going to talk about the responsibilities that both employers and employees share. Obviously, electrical safety. We're going to talk about how to keep our outlets safe. High amperage equipment that we may have in either the break rooms or other high amperage equipment that we may have out in the shop. And so we want to address all of these issues and make sure that when we do our inspections and we observe things going on out in the shop or out in the field, that we know what we need to do to make sure we don't create fire hazards. So keep that in mind, right? So when we talk about the fire triangle, we're talking about what we need for combustion, what we need to create a fire. And those three elements are heat, a fuel source, and oxygen. So when these three come together, have heat and or slash ignition, we have fuel, something that's combustible, something that's flammable, something that will burn basically. And we have normal oxygen in the atmosphere or more than normal oxygen. We have conditions where we can have fire. And so we want to avoid that as much as possible. So coming up, we're going to see a really nice graphic of how these three elements that are needed to create fire or create fire hazards, how they interact. And in most cases, when we try to put out a fire, we try to interrupt one or two of these angles or parts of the fire triangle. Especially when we use a portable fire extinguisher, an ABC fire extinguisher. Typically what happens is if you use it correctly and use the pass system, pull, aim, squeeze, and sweep at the base of the fire, you are displacing oxygen away from the fuel source, and as that dry chemical settles on the fuel, it helps cool down the fuel source. So we are in effect trying to disrupt two parts of the fire triangle. And that's a good thing to keep in mind. So a lot of times out in the field and around the shop, we have flammable liquids. Usually gasoline is the one that's most prevalent. You may have diesel and you may have other things that are flammable. But gasoline is probably by volume the biggest one, the most common one we deal with. It's important to realize what the flash point is. A flash point is a temperature where enough vapors come off the surface that a flame or some other source of heat or static electricity can start a fire. And since the flash point of gasoline is negative 49 to 45 degrees Fahrenheit, there's very few places I know of that there's not enough vapors coming off gasoline to create a fire. That's why approved self-closing cans are required. That's why it's important that we use approved cans, whether they be metal or plastic, and it's important that they close. Here's an example of basically a gold standard kind of metal safety can. I'm very happy that the newer ones come with funnels. That was one of my main complaints about using a safety can. I'm sure I'm not the only one that really disliked trying to pour gasoline into a lawnmower or other piece of equipment without a funnel on these safety cans. It became an issue. They have flame arresters on the inside, and as long as the can is maintained in good shape, it should last for a long time and not let the vapors escape. That's the key with the self-closing lid. And that way, as we don't have a lot of vapors, or we don't have any vapors, hopefully, escaping the can that can create a fire hazard. So, when we talk about eliminating fire hazards, every facility should have some kind of walk around check once every week, once every month. Someone should walk around the facility, the trucks, check the trucks for maintenance, check for other hazards like housekeeping and many things. And so while you're checking for those things, obviously checking outlet covers, make sure they're working correctly. The outlet covers are not cracked. Checking cords, both to make sure that they're not creating tripping hazards, as well as that they're in proper shape. And in fact, OSHA requires that cords be inspected before they be plugged in. This goes for all other cables and cords you might have in the facility also. As part of your walk around, however often you do it, we need to make sure that the smoke alarms work well. Make sure sprinkler systems that are installed are working correctly. Make sure that if you don't have a more modern system, that everybody is well aware of how to be when to be told, how to be told, how to interpret information if there's a fire or a tornado or some other kind of event where we have to take a place of safe refuge or leave the building in an orderly manner. And we need to be trained on where the fire exits are, how to escape, where the fire protection equipment is at, if you're going to be required to use them, who is going to do a head count and make sure everybody made it out. That's all important. So when we talk about doing the inspections, of course, identifying hazards is the first step. Once they're identified, we want to eliminate those fire hazards. So we're talking about removing anything, any material that's flammable or combustible away from electrical equipment. Of course, flammable, we've already talked about gasoline and fuels. That's very important. We also want to keep combustible material away from electrical equipment, which would be cardboard, any kind of wood product that can catch fire. This time of year, at the time of this recording, fall, we also want to look outside our facilities, look for dry leaves, limbs, things that have fallen off trees that may be around our propane tanks and other fuel sources. We do not want to leave portable heating devices unattended. More about electrical safety, we will be very careful with power strips. We don't want to overload them. We want to make sure that we use them appropriately. They're basically intended for computer and computer peripheral equipment, so we shouldn't have anything that's high amperage plugged into a power strip. We want to replace the worn, old, and damaged extension cords that we mentioned earlier. And if at all possible, we want to use power strips that have internal overload protection, things with a breaker or a fuse. We want to make sure that we take care of our cords, our flexible cords, is that the way they're spoken about or written about in OSHA standards, that we don't put them through doorways, windows, attach them to building surfaces, things where they can be pinched and damaged. We want to avoid that. As far as outlet safety, We obviously do not want to overload those outlets. Most outlets are either on 15 or 20 amp breakers, so we want to make sure we keep equipment plugged into them and make sure they're not overloaded. They don't exceed that amperage. We don't want to force three-prong cord into a two-slot outlet, which we shouldn't have many of those around. And if for some reason the outlet starts getting worn out because just use of plugging different equipment in it for different things that need to be done, we need to replace those. And we need to insert the plugs fully into the socket. And if, for example, in your facility, you have outlets out in the lobby where young children can interact with them, we want to make sure we have tamper resistant outlets. So when we're talking about high amperage equipment, typically in a break room or if you've got a laundry, we want to plug that major appliance directly into a wall outlet. We do not want to use power strips, as we've already said, with high amperage equipment. If we've got small appliances that are not used on a daily basis, they don't need to be plugged in all the time, then we want to remove those, take a little bit of load off of that circuit, put them in the place where they can't be torn up or the plug be modified or the cord broken or pinched, in those kinds of things. So we also all want to use light bulbs that match the wattage on the light fixture. Hopefully we're all aware of this, and it makes sense that if it says use a 60 watt bulb, then we use a bulb that does not go beyond 60 watts. We also do not want to use an extension cord with major appliances. We want to use the correct gauge for the amperage on our extension cords. If you need a 6 or an 8 gauge extension cord, then use that. We have to take into consideration the length of the run of the extension cord and the equipment we're running off of it, the load that we're placing on that. When we overload these extension cords, they get hot to the touch. If you have an extension cord that's getting warm, we know that the gauge then is not correct for the equipment you're using. So we want to try and avoid having anything, once again, that's combustible or flammable away from anything that produces heat, such as lamps or light fixtures or light bulbs. We want to be careful when we inspect our equipment. Anything that has a plastic or rubber coating and it's cracked or it's got some kind of defect in it, we want to replace it as much as we can. Remember, the key to this is making sure that we keep heat, fuel, and oxygen separated from each other. That's the fire triangle. We want to do routine inspections. We want to look for hazards. Once we identify the hazards, we want to work to eliminate the hazards. We want to make sure our fire equipment is working and ready to use. We want to train on fire escape procedures. Make sure that if you're required to use a fire extinguisher, you know the PASS system and how to deploy that. Make sure that we do inspections and make sure electrical safety, outlet safety, pay particular attention to our outlets, our cords, our plugs. Make sure they're all grounded and all that stuff is in right and correct order. Don't forget about high amperage equipment in the shop or break rooms. Make sure that those pieces of equipment are plugged directly into an outlet and that they are working correctly. I appreciate your time. If you have any comments or questions, please feel free to ask your JTNS instructor. As always, we don't know the answer to every question, but what we will do is do our best to try and find you an answer. So, once again, please do not hesitate to ask questions, and we'll do our best. Thank you for your time and your attention. Have a great day, and if this presentation has identified anything that you need to do or that you need to include in your routine inspections to try to prevent fire hazards in the shop, break room, and high amperage equipment, please do so. Thank you.